What up, future Hypixel devs, and welcome to my Minecraft plugin tutorial series in which you will actually learn how to code like a professional developer and elevate yourself from the default Minecraft plugin deving community. You will learn core concepts of the Java programming language, how to really understand what is going on in this Bukkit rabbit hole, and how to interpret and write modular, readable, and understandable code. Alrighty then, make yourself comfortable, get your notebook, if you want to write things down of course, and get ready to start your journey as future Hypixel developer. Before we get into anything, we must understand what we are dealing with. In this case, the language of course, in which we are coding in, which is Java. Java is based on the WARA concept, write once, run anywhere, which means that you can write the application once and run it on any device that provides a compatible JVM. You may be wondering how this is even possible when each device has a different architecture, dependencies, and so many more factors. The answer is the JVM, Java Virtual Machine. The JVM is an abstract execution environment that runs Java bytecode on top of the host operating system. The JVM is part of the Java runtime environment and is responsible for executing Java bytecode, handling memory allocation, garbage collection, and much more. Since we all have small monkey brains, I'll switch from pictures and text to a much more sophisticated, insightful, and an easier to understand environment.
Minecraft.
Let's take a closer look at the JVM. We won't visualize the operating system directly, since that would just add unnecessary complexity. For visualization purposes, we'll treat this Minecraft instance as our JVM environment. And with that in mind, let's start with the most important part of the JVM, memory. This Minecraft world represents the heap memory. The heap is the memory area where objects are allocated and live. For visualization purposes, we'll treat each block or entity as an individual block in the heap. Let's create a new object in the heap, which in our case is the cyan concrete powder block. Now a natural question is, how does Java access these objects? The answer is references. Objects don't store references to themselves, instead references live elsewhere and point to objects. We'll visualize those references using signs. As you can see, we currently have 3 references pointing to this object: a local reference, a field reference, and a static reference. This means that in Java, multiple references can point to the same object at the same time. Now this raises an important question. What happens when these references disappear? If we remove one reference, nothing happens. The object is still reachable. If we remove another one, still nothing happens. As long as at least one reference exists, the object remains alive in memory. Now what happens after removing the third and final reference? At this point, the object is no longer reachable, it is now eligible for garbage collection. This is where garbage collection comes into play. In some programming languages, memory has to be freed manually. Java works differently. Java has a garbage collector, which automatically reclaims memory that is no longer reachable, making it available for future objects. In Minecraft terms, this lava represents memory being reclaimed. When an object is no longer reachable, its memory can safely be reused. The object doesn't disappear instantly, but it is no longer considered alive. Garbage collection is not about deleting objects, it's about managing memory safely. With this brief technical introduction, we'll start by setting up our development environment, by first installing our IDE, also known as Integrated Development Environment. In this case, we'll use IntelliJ by JetBrains, since for our use case, it is the best. Simply follow my steps while installing. After the installation, you should have a similar window like this. First, we are going to configure the settings by clicking on the gear in the bottom left and pressing Settings. Then we click Editor, Code Style, Java, and go to the Imports tab. For me, it is already configured. It is not a must-have, but most people change the default import order, not a biggie. You're going to check the same things I am. Next up, click the Tabs and Indents tab and change the tab size and indent to 2. It should be 4 by default. Then you press the Editor tab on the left, go to General, Auto Import, and check the same things I have checked. And now, optionally, you can go to the Plugins tab and install a theme. The theme of my choosing is Gary's Themes. After installing it, you go to the Appearance tab and choose Gary Dark's theme. Then you scroll down to Advanced Settings and check the Islands UI thing since it looks nice. And now we can start writing code and create our first plugin. First, create a new project, give it a name of your choice, and I'm going to call mine my first plugin and change the project's location. Then we are going to pick Gradle as build system and hold your horses. Yes, we are going to use Gradle and not Maven. Why? Simply because it is better. I won't go into detail why, but I encourage you to use Gradle for your Java projects. Then we are going to select the Java development kit. In our case, we'll use version 21. If you don't have it installed, IntelliJ can install it for you by pressing download JDK. Now we are going to open up the advanced settings and quickly talk about group ID and artifact ID. The group ID simply defines who you are. It usually follows a reverse domain or name structure like me.yourname.projectname or com.yourdomain.projectname. This helps uniquely identify your project across the entire Java ecosystem. The artifact ID defines what this project is. In most cases, it's simply the project name written in lowercase. Now we are going to wait for the build system to fully import and set all the settings. Alright, now that everything is set up, we can look at the file structure. For some reason it created an .iml file. We can delete that. We now have a settings.gradle.kds file and a build.gradle.kds. For now, we only care about the build.gradle.kds. One more thing we must install is the Minecraft server. How are we supposed to use plugins when we have no environment for them? Simply search for PaperMC in the browser search bar and download the latest PaperMC build. Before we continue, let's quickly clarify what plugins actually are. Plugins are server-side extensions. They run only on the Minecraft server and allow us to change behavior without modifying the game itself. In the early days of Minecraft, there was no plugin system. Server owners had to modify the server's internal game code directly, which was fragile and broke with every update. To solve this, Bukkit was created. Bukkit introduced a stable API, an application programming interface that exposes safe hooks into the server. Instead of modifying the game code, plugins interact with the server through this API. Spigot later built on top of Bukkit with performance improvements. Paper builds on Spigot and adds even more optimizations and additional API features. Think of the API as a contract. The server guarantees certain behaviors and plugins rely on those guarantees. Now drag the paper jar file into the directory of your choice. I'll create a test server directory. After doing that, we go back to our IDE and make the IDE execute our server. Just follow my steps. First, we'll create our own configuration, in this case a jar application. The path to the jar is the paper jar file. Now we have VM options. We'll add basic ones to make it run. Those are -dpaper.ignore_java version equals true, -xms2g, -xmx2g, -xx: plus use g1gc. Those are basically RAM configurations and garbage collection configurations. Then we put -no GUI as argument, since we don't need that. The working directory is the directory where our jar file is located in. The JRE is going to be version 21. And then we can run this application, and in the IDE a terminal window should open. It will prompt you to accept the EULA, so we go back to our server directory and locate the EULA.txt file. Open it and set it from false to true. Ctrl S to save. Then run the application again and the server should be up and running. Before we join the server, we need to build our first plugin, and for that we have to configure our build.gradle.kds file. This file tells Gradle how our plugin should be built. It defines things like which Java version we use, which libraries we depend on, and how the final plugin jar is created. Think of it as a build recipe, not game code. This can look overwhelming at first, so I'll keep it focused and only explain what's actually necessary. If you have questions, feel free to ask them in the comments. At the very top, we import org.gradle.jvm.tasks.jar. We'll need this later when we customize how our plugin jar is built. Next is the plugins section. Since we're building a Java plugin, we tell Gradle to use the Java plugin. This has nothing to do with Minecraft, it just enables Java build tooling in Gradle. Then we define the group and version, which identify our project during the build process. We've already talked about those earlier. Now we are going to define a few variables. These simply store paths to our test server, the paper jar, and the plugins directory, so we can reuse them later in the script. The repository section tells Gradle where it's allowed to download libraries from. Maven Central is the default Java repository, and the paper repository hosts the paper API. Next up are dependencies. Our main dependency is the paper API. We mark it as compile only because we need it to compile, but we don't want to bundle it into our plugin jar, since the server already provides it at runtime. Then we'll define the Java toolchain. This ensures our plugin is built using the correct Java version. Now we'll customize the jar task. Here we control the name of the output jar and add some build metadata to the manifest. This isn't required for paper, but it's considered a best practice. After that, we'll register our first custom task called deploy to server. This task builds the plugin jar and copies it into the server's plugins directory. Finally, we register another task called run server. It runs deploy to server first and then starts the paper server automatically. This way, we don't have to rebuild, copy, and restart the server manually every time. After finishing writing the script, we first have to see if everything is valid by pressing on the small elephant icon. If it is all valid, go to the top part where we firstly configured our server executable, press the arrow and press Edit Configurations. Then click the plus icon and add a Gradle task. You can name it however you like. And in Run, we are going to type in colon run server, which is the task we created in the script. Now you can press the green arrow and it should ship the code into the plugins directory. The only thing missing now is the actual plugin code, so let's get on and write it. The main folder structure of almost all Java projects is source/main/java/package names. So we'll go ahead and right click on the Java directory, hover new and then click new package. We are going to call it me.yourname.example plugin or whatever you prefer. After creating the package, we have to create a class, in this case our main class. Right click on the example plugin, part of the package and hover new and create new Java class. Class names should be nouns, in mixed case with the first letter of each internal word capitalized. I'll call mine my first plugin. All plugins must extend Java plugin, which means that our class is now a subclass of Java plugin, which is our parent class. The Java plugin class lives inside paper. That way, when we have methods like onEnable or onDisable, we can use them, but we don't have to implement them since paper already implemented them for us. There are two methods every Java plugin uses, since those are the entry points for the plugin. These methods are onEnable and onDisable. The @override annotation above is optional. It is to show us that this method is already implemented by some other class or interface. You can view the parent class by pressing Ctrl, click on Java plugin, and then you can see how it all functions internally. I skipped over the internal part since it is too much for this video. I'll explain more in the future. Now let's focus on our plugin. Let's create the simplest kind of plugin, one log in onEnable and onDisable. We are going to take advantage of our parent class, Java plugin, which has a getter for an object called getLogger. So let's write getLogger and let's call the log method in this object by typing .log. Now this method has two parameters, the log level and the message, so we'll feed it those parameters. Now the last step is to create a plugin manifest file, which is called plugin.yaml. Right click on resources and create a new file and call it plugin.yaml. We need this because paper doesn't know what class is our main class, so we'll define it for paper. And there are several other attributes or metadata to configure, but I'll just go over the necessities. Main is our main class path. Name is the plugin name, version is the version, author is the author, description is a description of the plugin, API version is what API version the plugin uses, and that database is if the plugin uses a database. This is very narrowly explained because you won't actually, I mean, it's pretty self-explanatory at this point. Yeah. After changing the first parameter to info instead of finest, we can run our Gradle task, and in the console you will see our plugin logging our message. This is the end of the video. Thanks for your attention. I hope I could help you learn new things. Please give feedback on maybe what type of plugins you want to see, or maybe general feedback about my video style. And have a good one. Cheers.